I want you to picture something with me for a second.
Okay, I'm with you.
And I really need you to strip away all the usual, the noise of everyday life to really visualize the sheer scale of this.
Right, yeah. It takes a second to really grasp it.
It does. So imagine the endless, freezing, absolute pitch black vacuum of space.
Okay.
It is completely silent. There is no wind, no atmospheric hum, just nothing.
Just total emptiness.
Exactly. But hurtling through that silence right at this very moment is a piece of human-made metal that weighs 4 tons.
Which is just a staggering amount of weight.
It's 8,800 pounds of dead weight. I mean, we're talking roughly the size of a 5-story office building.
Or like a school bus, right?
Yeah, a massive school bus. And it is flying through the void at 5,400 miles per hour.
Just coasting.
Completely coasting. It has no pilot. It has no steering mechanism, absolutely no brakes. And it is dead set on a direct, completely unavoidable collision course with the moon.
It really is the ultimate unstoppable force, meaning a very immovable object.
Yeah, the moon isn't getting out of the way.
Definitely not. And the resulting transfer of energy from that crash is going to be something we rarely get to witness in such a, controlled, predictable way.
Okay, let's unpack this, because on the surface, this sounds like a monumental screw-up, right?
Oh, absolutely.
I mean, we lost a building-sized piece of a rocket, and now it's about to just slam into the moon on Wednesday.
Yeah.
The initial reaction you'd expect from the scientific community would be panic, or at least some serious finger-wagging at SpaceX.
You'd think so, yeah.
But they aren't panicking. I was reading these reports from The Guardian and the BBC, and scientists seem almost like giddy about it.
They are thrilled.
We are looking at a situation where a massive piece of space junk is about to become the center of the entire astronomical world.
What's fascinating here is the sheer irony of the entire situation.
Irony, how?
Well, if you look at this purely from an operational standpoint, this is essentially an act of celestial littering.
Right. We just tossed it out a window.
Exactly. It is carelessness in space disposal. We left our trash out, and the universe took it for a ride.
A very fast ride.
Right. But because of the specific physics of where it's crashing and how fast it's going, this completely accidental piece of garbage is about to trigger an unprecedented, massive, and highly anticipated global science experiment.
Which is wild to think about.
It is. I mean, astronomers couldn't have mathematically modeled a better impact if they tried.
So for you listening right now, I want you to imagine walking outside on Wednesday night. You look up at the moon, that same silent, glowing rock that humanity has stared at for, millennia.
Yeah, since the dawn of time.
But on Wednesday, when you look at it, you will know that in real time, human history is literally leaving a brand new, violent dent in its surface.
We're actually altering the geography of the moon as we speak.
We are. So let's look at the sheer physical stakes of what is about to happen, because the numbers here, they're just hard to wrap your head around.
They really are.
We're talking about the upper stage of a SpaceX Falcon 9 rocket.
Well, to be precise, it's the second stage.
Okay, second stage.
And that distinction matters a lot for why it's up there, which I know we will get to. But physically, it's a massive empty cylinder composed mostly of aerospace-grade aluminum and lithium alloys.
And it weighs 4,000 kilograms. I mean, imagine taking a 5-story office building and flying it from London to New York in under an hour.
It's hard to even picture that kind of speed.
It is. It's traveling at roughly 2.43 kilometers per second, which translates to about 5,400 miles per hour.
So screaming fast.
And its final destination is a place called the Einstein Crater, which is located on the moon's western limb.
Which is great for visibility from Earth, actually.
Right. And the impact time is set for this coming Wednesday, August 5, 2026, at precisely 06.35 GMT.
Down to the minute.
Down to the minute. When I try to visualize those numbers, I just struggle with the sheer kinetic energy involved. We are talking about thousands of pounds of metal moving at like rifle bullet speeds.
It is an astonishing amount of kinetic energy. And to truly appreciate it, you kind of have to throw out your earthly intuition about how things crash.
What do you mean by that?
Well, when we drive a car at 60 miles an hour and hit a wall, there's engine power involved, right?
Sure.
But there is also friction from the tires, wind resistance pushing against the windshield, and gravity pulling the car down against the pavement.
Okay, yeah.
This rocket stage has literally none of that. It is completely unpowered and uncontrolled. It is just drifting.
Just a dead weight.
Exactly. But because there's no air resistance in the vacuum of space to slow it down, It maintains that terrifying velocity indefinitely.
Because there's no drag, it's just inertia carrying it forward.
Yes, Newton's first law in its purest form. An object in motion stays in motion, and the math behind the impact is where it gets really terrifying.
Walk me through the math.
So, kinetic energy is calculated by taking half of an object's mass and multiplying it by the square of its velocity. It's the square part of that equation that really matters, because the velocity here is so incredibly high, 2.43 kilometers per second. The energy upon impact grows exponentially compared to its mass.
Wait, let me make sure I'm getting this. So if you double the weight of the rocket, you just double the energy of the crash, right?
Right, it's linear.
But if you double the speed of the rocket, you quadruple the energy of the crash.
You've got it. Velocity is the dominant factor in kinetic energy.
Wow.
When that metal hits the lunar regolith, all of that forward motion, all of that massive stored energy, it can't just disappear.
Right, conservation of energy.
Exactly. The laws of thermodynamics dictate it has to go somewhere instantly. It converts into a massive shock wave of heat, light, and mechanical force.
That's incredible. Now, just to reassure everyone, there is absolutely zero danger to Earth.
Oh, none. The moon is 250,000 miles away.
Okay, good. But the sheer mass and the extreme velocity guarantee that this impact event will be violently spectacular.
It's basically a massive kinetic bombardment.
And the fact that we know exactly when and where it's going to hit, down to the minute, feels like a magic trick, considering this thing is essentially lost in the woods.
It really is a marvel of tracking.
Which brings up the massive 5-story elephant in the room.
How do you lose it?
Yes. How do you lose something this big? I mean, we track tiny satellites in orbit all the time.
We do.
Tracing this rogue rocket's journey over the last year is just a wild ride because it really defies how most people think space travel works.
To understand the crash, we have to go back to the launch, which took place over a year ago in January 2025.
Okay.
The mission profile is key to understanding why this piece of metal became a rogue projectile in the first place.
Right. So the original mission was carrying a pair of lunar landers for Firefly Aerospace, which is part of a joint U.S.-Japanese initiative, sending them toward the moon.
A very heavy payload.
Yeah. Now, we all know SpaceX for those incredible videos where the first stage of the rocket gracefully lands itself back on a drone ship in the middle of the ocean.
Right. Everyone has seen those clips.
But this object is the second stage.
Yeah, the second stage is the workhorse that takes over once the rocket is already out of the thickest part of Earth's atmosphere.
So the first stage just does the heavy lifting off the ground.
Exactly. The first stage gets you off the launch pad. The second stage gets you to your actual destination.
Got it. And because this specific mission was sending heavy landers all the way to the moon, it required massive prolonged thrust.
Right. It's not just popping something into a low orbit a few hundred miles up.
No, it had to push these landers across 250,000 miles of space. So once this second stage did its job and deployed the payload, it basically dumped whatever tiny amount of fuel it had left.
Standard procedure.
Right. It was completely empty. And because it was so far out, it lacked the energy to turn around and return to Earth's atmosphere to safely burn up.
And that is a crucial distinction in orbital mechanics.
How so?
Well, when you launch a Starlink satellite into low Earth orbit, disposing of the rocket stage is relatively easy. Earth's gravity is incredibly dominant there, and even a few hundred miles up, there are, stray molecules of atmosphere that create a tiny bit of drag.
Oh, so it just naturally slows down.
Exactly.
Yeah.
You just use a tiny burst of fuel to nudge the rocket's trajectory down a bit, and friction does the rest. It burns up safely.
Makes sense.
But a lunar insertion trajectory pushes that hardware out to the absolute edge of Earth's gravitational dominance.
But wait, if it's out of fuel and Earth gravity is getting weaker, why wouldn't it just stay where it is? Or just fall back very, very slowly?
It seems like it should, right?
Yeah. I mean, we launched the state-of-the-art rocket, deployed the payload, and then just left the building-sized leftovers floating in the void. How did it end up aiming for the moon?
It sounds absurd, but you have to stop thinking of space between the Earth and the moon as an empty, static void.
What is it then?
It is a highly chaotic, invisible web of gravitational pulls. You have the Earth pulling on the rocket. You have the moon pulling on it. The rocket is constantly caught in a tug of war.
Okay, so it's getting yanked in both directions.
Right. But the wild card here, the thing that actually pushed it over the edge into this collision course, was the sun.
The sun? Like solar flares? Or just the gravity of the sun?
Neither, actually. It was the physical light from the sun.
Wait, what?
Yeah, a SpaceX director explained that it was a mixture of solar activity and gravity forces that pushed it onto this specific trajectory. This is a phenomenon called solar radiation pressure.
I'm going to need you to slow down and explain that, because my understanding of high school physics is that light is made of photons, right?
Yep.
And photons do not have mass.
Correct.
If they don't have mass, how can they physically push a 4-ton piece of aluminum?
That is the perfect question, and it really gets into the weirdness of quantum mechanics. It is true that photons have no resting mass. However, they do have momentum. When light hits an object, it transfers that momentum to the object. Think of it like billions of infinitesimally small ping pong balls bouncing off the side of the rocket every single second.
But the force has to be incredibly tiny.
Oh, it is microscopically tiny. I mean, if you hold your hand out in the sunlight right now, you are being pushed by solar radiation, but the friction of your shoes on the ground makes it entirely unnoticeable.
Right.
But the rocket stage is in a vacuum. It is a massive, highly reflective, hollow cylinder. It acts almost like a solar sail.
Oh, wow.
So over weeks and months, that gentle, relentless push from the sunlight day in and day out fundamentally alters the rocket's trajectory.
That is mind-blowing. The sheer relentless pressure of light over a year actually steered a school bus made of metal.
It did. Combined with the shifting gravitational fields of the Earth and the Moon, it creates what physicists call the N-body problem.
The N-body problem.
Yeah, if you only have two bodies in space, like the Earth and a satellite, the math to predict its path is pretty simple. Sir Isaac Newton solved it centuries ago.
Okay, sure.
But the moment you add a third body, the moon, and a fourth influence, solar radiation pressure, the math becomes highly chaotic. It becomes a probability cloud rather than a fixed track.
So it's basically the butterfly effect.
Yeah.
A tiny push from sunlight completely changes where it ends up a year later.
Exactly.
And the craziest part of this journey to me isn't even the quantum physics of sunlight. It's how we actually found out it was crashing. Because SpaceX didn't raise the alarm.
Yep, they didn't.
NASA didn't put out a press release either. The discovery of this impending collision was made by a guy named Bill Gray.
Bill Gray is a fantastic example of how modern astronomy actually functions behind the scenes.
Yeah. He is an independent astronomer and the creator of a piece of software called Project Pluto.
Right.
He essentially crowdsources observations from amateur and professional astronomers all over the world. They track objects in the Earth's space, feed the coordinates into his software, and it calculates the future trajectory of these objects.
It's brilliant software.
He ran the numbers on this specific piece of junk and realized the orbit was decaying directly into the moon. He literally published a report saying, "Hey everyone, check my math, but this thing is going to hit the moon."
It really highlights a massive blind spot in our institutional space tracking.
How so?
Well, governments and space agencies like the U.S. Space Command track active satellites and debris in Earth orbit very closely, to prevent collisions.
Because that would be disastrous.
Exactly. But once a rocket stage is declared dead and is flung out into deep space, institutional tracking often just drops it from the priority list.
Out of sight, out of mind.
Precisely. It is the independent astronomy community, using public data and telescopes in their backyards, who act as the watchmen for this deep space debris.
Gray's discovery forced the major agencies to turn their massive, multi-million-dollar instruments toward the object and confirm that his math was correct.
Which it was.
I love that a guy with clever software and a network of hobbyists spotted the 4-ton runaway train before the agencies did.
It's a great underdog story.
It really is. So we know what it is, and we know how sunlight and chaotic gravity pushed it onto this doomed path. Now, we need to zoom in on the exact moment of impact, because the physical environment of the moon is going to make this crash unlike anything we could ever replicate here on Earth.
The physical environment changes everything. This shifts the story entirely from a logistical failure to a scientific goldmine.
Let's look at the raw physical outcome of this collision. When this 5,400-mile-per-hour rocket hits the Einstein Crater, it is going to violently carve out a brand new crater roughly 60 feet wide and 12 feet deep.
Which is almost 20 meters across and 4 meters deep, excavated in just a fraction of a second.
But it doesn't stop there. The impact is going to launch a massive plume of dust and rock, which scientists call ejecta.
Right.
And this plume could potentially shoot 50 kilometers into the air, spreading sideways over time.
50 kilometers.
That's over 30 miles high.
And that 50-kilometer plume is exactly why astronomers are rearranging their schedules to observe it. Dr. Matt Bothwell, who's a public astronomer at the University of Cambridge, pointed out that this event will be more impressive than any similar explosion on Earth.
I read that quote.
And the reason for that magnitude is entirely due to the moon's unique physical properties.
Here's where it gets really interesting for me. I was trying to picture this 50-kilometer plume and why we can't just simulate this in a desert on Earth, right?
Okay. Yeah.
So I came up with this analogy. If you take a bowling ball and drop it from an airplane over the Sahara Desert, our atmosphere acts like a thick, resistant fluid.
It definitely does.
It provides drag. The air heats up, it creates friction, and it acts like a parachute, slowing the bowling ball down before it hits the sand.
Yes, terminal velocity.
Exactly. And when it does hit, the air pressure suppresses the sand from flying too high.
Right. The air physically pushes back down on the dust.
But hitting the moon is like dropping a bowling ball onto a massive pile of flour inside a total vacuum chamber.
That's a great visual.
There is zero resistance on the way down and absolutely nothing to push back on the flour when it explodes outward.
That is a highly accurate way to visualize it. Because the moon has no atmosphere, there is no atmospheric drag during the descent. The rocket doesn't heat up, it doesn't melt, and it doesn't shed any mass or speed before impact.
It just hits full force.
It hits the ground with 100% of its mass and 100% of its kinetic energy intact.
But wait, if there's no atmosphere, shouldn't some of that dust just keep floating away into space? Why does it only go 50 kilometers high?
Because the moon still has gravity, even though it's much weaker than Earth's.
Right, it's like 1/6 of Earth's gravity, isn't it?
Yes, roughly 1/6. When the immense kinetic energy of the rocket is transferred to the lunar rock, it shatters the surface.
Yeah.
On Earth, the thick atmosphere would absorb a lot of that energy by creating a massive shock wave of sound, and the air resistance would quickly slow down the flying debris.
It would pull it back to the ground within a few hundred feet.
Right. But on the moon, there is no sound. There is no air resistance to steal momentum from the flying rocks. An estimated 1 million kilograms of lunar rock and dust will be violently ejected upward in a vacuum.
1 million kilograms.
Yeah. And it travels in perfect, unhindered parabolic arcs until the moon's weak gravity slowly, eventually pulls it back down.
1 million kilograms of debris shooting 30 miles into space. It's just staggering.
It's beautiful physics.
But here is the question I have. Why is this specific plume of dirt so exciting to scientists? I mean, we've landed on the moon.
We have.
The Apollo missions brought hundreds of pounds of moon rocks back to Earth. We have rovers driving around up there right now.
Yeah.
What is so special about this specific cloud of dust?
The scientific gift here is not the dust itself, but the depth from which it is coming.
Oh, the depth.
Right. The rocket is going to dig a hole 12 feet deep into the lunar regolith.
Okay, so it's a deep hole.
And for billions of years, the very top surface of the moon has been relentlessly baked by solar radiation, blasted by cosmic rays, and pulverized by micrometeorites.
So it's beaten up.
Highly beaten up. The top layer is highly weathered and chemically altered from its original state.
Ah, so it's like looking at a rusted car. The surface doesn't tell you what the metal underneath is really made of.
Exactly. This accidental rocket impact is acting as a massive, high-speed, entirely free excavation tool.
Free for the scientists, anyway.
Right. It is going to punch right through that weathered crust, dig 12 feet down, and throw fresh, pristine, completely unexposed subsurface lunar material up into the sunlight for the very first time in billions of years.
We're essentially getting a deep core sample for free, courtesy of SpaceX losing their garbage.
It's exactly what it is. And by analyzing the light reflecting off that freshly exposed ejecta plume, scientists can read the chemical signature of the moon's subsurface using spectroscopy.
What are they looking for?
They can look for water ice, trapped gases, and rare minerals without having to design, fund, and launch a billion-dollar drilling rover to do it.
That is incredible. A multi-million-dollar mistake turns into a priceless geological survey.
It's a happy accident.
And this promise of analyzing fresh subsurface material naturally leads us to the massive global effort to observe the crash. Because nobody in the astronomical community wants to miss this microsecond event.
Nobody.
There's a literal global watch party forming right now.
It is a highly coordinated international effort.
Yeah.
Every telescope that can point at the moon is being scheduled for this exact moment.
Which made me wonder, if I walk out into my backyard on Wednesday night, What am I actually going to see? Can I just set up a lawn chair and a pair of binoculars, or do I need a billion-dollar observatory to get in on the action?
You should definitely manage your expectations for backyard viewing.
Darn.
Yeah, unfortunately, the impact site, the Einstein Crater, is located on the moon's western limb.
What does that mean for us?
That means it's right on the edge of the visible side of the moon from our perspective on Earth. Because of the angle, the crash itself likely won't be visible to the naked eye.
So no giant Michael Bay fireball in the sky.
Definitely no fireball. A fireball requires oxygen to sustain combustion, and there is none on the moon. Furthermore, 250,000 miles is just too vast a distance to see a 60-foot event with the naked eye.
Okay, that makes sense.
However, Dr. Bothwell noted that if you have access to a sophisticated, high-end amateur telescope and you know exactly where to look, you might just be able to catch a quick, extremely bright flash radiating off the lunar surface at the exact moment of impact.
Wait, there's no fire. What is the flash?
The flash is the raw thermal radiation, the heat and light generated instantly by that massive kinetic energy transfer we talked about earlier.
Oh, from the sheer force of the metal hitting the rock.
Yes. When the metal compresses the rock, the friction and pressure create a momentary burst of intense heat that glows brilliantly in the infrared and visible spectrums.
But the professionals are not leaving this to a lucky glance through a backyard telescope.
Oh, no.
The big guns are coordinating. Huge telescopes across the Americas are aligning their observation times. More importantly, we have assets that are already in space, much closer to the action, right?
We do.
NASA has their Lunar Reconnaissance Orbiter, or LRO, circling the moon right now. And South Korea has their Danuri probe up there as well.
Both incredible pieces of hardware.
And they are actively adjusting their orbits to track the flash, watch the plume rise, and analyze that fresh subsurface ejecta.
The collaborative nature of modern astronomy is incredibly impressive here. You have NASA, the South Korean Space Agency, independent astronomers like Bill Gray, and thousands of citizen science participants all uniting their focus on this one rogue piece of metal.
That's phasing.
And while the chemistry of the dust is important, what they are really trying to do is sharpen our computer models of lunar impacts.
Wait, how does watching a modern SpaceX rocket crash help us understand the moon's history?
Because the physics of an impact in a vacuum are universal. The moon's surface is essentially a pristine, undisturbed historical record of asteroid strikes over billions of years.
Right, because there's no wind or rain to wash the craters away.
Exactly. Every crater on the moon tells a story about the violent history of our solar system. But we rarely, if ever, get to see a crater form in real time, knowing the exact mass, speed, and trajectory of the object creating it.
Right. If we look at a crater from 1,000,000 years ago, we have to guess how big the asteroid was based on the size of the hole.
Precisely. We are just working backward with estimates, but here we know the exact dimensions, weight, and velocity of this Falcon 9 stage.
It's a known quantity.
Exactly. So observing the resulting crater and the dispersion of the dust plume allows scientists to calibrate their mathematical models. It provides a highly accurate ground truth.
Oh, I see.
If we know a 4,000-kilogram object traveling at 2.43 kilometers per second makes a 60-foot crater, we can reverse engineer the math with much greater accuracy.
To understand exactly how big and how fast the asteroids were that created the massive ancient craters we see all over the lunar surface.
Exactly. It's the ultimate control group for a solar system-wide experiment.
We know exactly what the bullet looks like, so we can study the wound to understand all the other wounds from millions of years ago.
That's a perfect way to put it.
But, as I was looking at the history of asteroid impacts, it transitions perfectly into something a bit more unsettling.
Yeah.
The moon is famously pockmarked by millions of years of random space rocks, but recently, it is becoming a graveyard for human spacecraft.
It really is.
Let's look at the historical context of humanity throwing metal at the moon, because this is becoming a habit.
It is a trend that is accelerating. The moon is slowly transitioning from an untouched celestial body into an archaeological site of human ambition and, quite frankly, our mechanical failures.
Let's run down the list, because this upcoming SpaceX crash isn't the first time we've hit the moon, and it's not even the first time we've done it by accident.
No, not at all.
First, there are the intentional calculated crashes. Back in 2009, NASA intentionally crashed an empty rocket stage into the moon's south pole for the exact same reason we just discussed, to study the resulting plume.
The LCR-OS mission.
Right, and that mission was a huge success. It churned up material from a permanently shadowed crater and helped confirm the presence of water ice.
That is the gold standard for an impact. It was planned, the trajectory was optimized for data collection, And all the orbital observatories were aligned perfectly in advance.
But then there are the accidental or failed landings. And this list is getting uncomfortably long.
Is.
In 2019, Israel's Beresheet lander suffered a gyroscope failure and slammed into the surface.
A heartbreaking loss.
Later that same year, India's Chandrayaan-2 lander lost communication and crashed during its final descent.
Yeah.
And then in 2023, Russia's Luna 25 mission spun out of control and created a new crater.
And those were all spacecraft that were actively trying to land softly but suffered technical or software failures at the very last moment. They were scientific missions that met tragic ends.
Right, but then there's the actual bona fide space junk, the stuff we just forgot about and lost track of.
The careless stuff.
Yeah. This SpaceX crash isn't the first time that has happened either. A Chinese Long March 3C rocket stage, which was a leftover piece of hardware from their 2014 Chang'e 5T1 mission, drifted around the cosmos for years and eventually crashed into the far side of the moon in March 2022.
Just completely uncontrolled.
We are literally turning the moon into an interstellar parking lot for bad drivers and forgotten trash.
This raises an important question, a critical debate within the aerospace community right now, actually.
What's the debate?
We have to draw a very sharp ethical and operational line. On one side, you have intentional, highly calculated scientific impacts, like NASA's 2009 mission.
Okay, the planned ones?
Right. Those are designed to yield maximum data with minimal contamination. On the other side of the line, you have the accidental, careless impacts of discarded junk, like the 2022 Chinese rocket and this upcoming 2026 SpaceX rocket.
So if the moon is just a dead rock, why does it matter if the metal hitting it was aimed on purpose or just drifted there by accident? I mean, a piece of aluminum is a piece of aluminum, right?
Well, it's not always just dead metal. When we lose control of a spacecraft, we lose control of what it deposits on the lunar surface.
What do you mean?
And that brings us to perhaps the most fascinating and frankly bizarre detail hidden in the history of these crashes.
Oh, this is the part that completely blew my mind when I was prepping for this deep dive.
It's wild.
So remember I mentioned Israel's Beresheet lander that crashed in 2019?
Yes.
It wasn't just carrying cameras and magnetometers. It was carrying a biological payload.
Yes, it was.
Specifically, it was carrying thousands of microscopic animals called tardigrades, also known as water bears.
Tardigrades are microscopic invertebrates that are famous in biology for being functionally indestructible.
They can survive extreme radiation, boiling water, the freezing vacuum of space, crushing pressures, you name it.
They are survival specialists.
When that lander crashed into the moon at hundreds of miles an hour, the container holding them shattered, and those tardigrades were scattered across the lunar regolith. We might have accidentally seeded the moon with indestructible microscopic water bears.
It is a quirky detail for sure, but the biological mechanism behind their survival is astonishing, and it really has profound implications for how we treat other planets.
Right.
Tardigrades survive these extremes by entering a state of suspended animation called cryptobiosis.
How do they do that without freezing and bursting? I mean, if you put a living cell in the vacuum of space, the water inside it should instantly boil and then freeze, rupturing the cell walls.
That's exactly what happens to almost all other life forms. But tardigrades have a unique evolutionary trick.
Which is?
When they sense extreme environmental stress, they expel almost all the water from their bodies. To prevent their cell walls from collapsing or crystallizing, they synthesize a massive amount of a unique sugar called trehalose, which essentially replaces the water and turns their internal cellular structure into a glass-like state.
A glass-like state? That's insane.
It is. They pause their metabolism down to less than 0.01% of normal. Scientists believe it is highly likely that thousands of those tardigrades survived the physical shock of the 2019 crash and are currently sitting on the moon, completely dormant in that glass-like state, waiting for a drop of water to wake them up.
We literally littered the moon with Earth biology. It's equal parts hilarious and terrifying.
It really is.
But it perfectly illustrates the danger of uncontrolled impacts. When we hurl objects at the moon haphazardly, we aren't just leaving craters, we are potentially contaminating the very environment we are trying to study.
Planetary protection is a major field of study. When NASA or the ESA sends a rover to Mars, the spacecraft is baked in sterilization chambers for days.
Right, to kill any hitchhikers.
Exactly. The engineers wear full hazmat suits just to touch it because we don't want to accidentally discover life on Mars, only to realize a week later that it was just bacteria that hitched a ride from a laboratory in Florida.
That would be embarrassing.
Highly embarrassing.
Yeah.
But space junk isn't sterilized for planetary protection, it's just trash.
And speaking of trash, This brings us to the final and perhaps most pressing part of our deep dive today.
The earthly consequences.
Yeah. Moving away from the lunar graveyard, this entire SpaceX crash forces us to zoom out and look at the broader, incredibly dangerous issue of space junk clogging up our own Earth orbit.
Which is a much more immediate problem.
And honestly, we have to talk about the earthly financial realities of the company responsible for this latest mess, because the economics of space explain exactly why this is happening.
The situation in Earth orbit is far more precarious than the situation on the moon. The moon is massive, and space junk impacts there are still relatively rare.
Right.
But right above our heads, in low Earth orbit, it is getting uncomfortably crowded, and the physics of a crash there are entirely different.
I was looking at the statistics from the European Space Agency, and my jaw dropped. They estimate there are currently over 54,000 objects larger than 10 centimeters floating in space around Earth.
Just swirling around us.
Since the dawn of the space age in 1957, humanity has launched 17,000 tons of objects into space. And a huge portion of that mass is just dead satellites, spent rocket stages, and jagged shrapnel flying around the planet at 5 miles a second.
This is where Dr. Bothwell issues a very stark warning in the reports. He talks about the fear of a runaway cascade.
What's a runaway cascade?
In aerospace engineering and orbital mechanics, this mathematically modeled worst-case scenario is known as the Kessler syndrome, named after NASA scientist Donald Kessler, who proposed it in 1978.
I feel like people know the Kessler syndrome from the movie Gravity, right? Where the space station gets completely shredded by a wave of debris. Is that actually how it works?
The movie dramatized it by making it a single, tightly packed wave of debris that comes around every 90 minutes. In reality, it's a slower, much more insidious statistical buildup.
How does it start?
The idea is terrifyingly simple. Because orbital velocities are so high, often exceeding 17,000 miles per hour, if two dead, uncontrolled satellites cross paths and collide, they don't just bump into each other and bounce off. They absolutely obliterate each other. The sheer kinetic energy shatters both satellites into thousands of pieces of high-speed shrapnel.
And then those thousands of pieces act like buckshot moving at rifle speeds.
Yes. That shrapnel doesn't fall to Earth immediately. It continues orbiting, but the explosion spreads it outward into different orbital planes. Eventually, one of those pieces of shrapnel hits another satellite, which shatters into 10,000 more pieces.
Oh, wow.
Which then hits two more satellites. It is a chain reaction of destruction. If a runaway cascade triggers in low Earth orbit, it wouldn't happen overnight. But over decades, it could create an impenetrable, chaotic shell of high-speed debris around the Earth.
We'd be trapped.
We would. It would destroy our global communications networks, our GPS, our weather monitoring, and make future space travel physically impossible for generations. It is a ticking time bomb.
That is legitimately apocalyptic for modern civilization. I mean, we rely on those satellites for almost everything.
We really do.
So what are we actually doing about it? The reports mention that NASA and SpaceX are currently in talks to prevent future lunar impacts and deal with orbital debris.
Which is a step in the right direction.
But while they are having these talks about space hygiene, we have to look at what's happening on the ground. SpaceX just released its first quarterly report as a newly public company.
And the numbers are very telling.
The contrast is wild. They reported a massive surge in revenue, and they posted a smaller loss than Wall Street expected. They're bringing in massive amounts of cash.
Right.
Yet their shares tumbled because investors remain skeptical over their lofty, expensive promises.
It's a tough market.
We have a company capable of successfully sending landers to the moon. They are surging in revenue, yet they are leaving 4 tons of trash in orbit to crash into the moon, and Wall Street is punishing their stock anyway. Are the economics of the modern space race pushing us to be careless?
You are looking at the dual reality of the modern commercial space age. It is a classic tragedy of the commons, just scaled up to orbit.
Explain the tragedy of the commons in this context.
Sure. On one hand, we are achieving unprecedented aerospace milestones. Launch costs have plummeted drastically because of reusable first stages. Access to space is being democratized, and engineering marvels are happening daily.
It's a golden age of spaceflight.
It is. But on the other hand, we are fundamentally failing at the basic hygiene of spaceflight tracking and capturing the dead hardware.
Because there is absolutely no profit margin in taking out the trash.
It's pure economics. SpaceX is under immense pressure as a newly public company. Investors want to see rapid growth, higher launch cadences, and the deployment of massive revenue-generating constellations like Starlink.
Right.
The slow, methodical, and highly expensive engineering required to track, capture, and safely deorbit spent second stages doesn't generate a dime of revenue.
It's just a sunk cost.
Exactly. It requires extra fuel, extra hardware, and extra weight on the rocket, which eats directly into the payload capacity and the profit margins.
Yeah, that makes sense from a business standpoint.
The earthly reality of quarter-to-quarter financial reports directly clashes with the long-term, multi-generational need to keep the orbital environment clean. The tumbling stock price, despite a revenue surge, shows how volatile the space economy is, and in that hyper-competitive, volatile environment, carelessness in disposal becomes an accepted financial externality.
It's the exact same thing humanity did with the oceans during the Industrial Revolution.
That's a great comparison.
Factories just dumped their waste into the water because the ocean seemed infinitely large and totally free to use. Until it wasn't. Now space is the new ocean, and we are filling it with high-speed metal because it's cheaper than cleaning it up.
It is a very apt historical parallel, and until there are binding international regulations with severe financial penalties for leaving space junk in orbit, the economic incentive will always lean towards abandonment rather than cleanup.
Because no one wants to be the first to take the financial hit.
Exactly. A company isn't going to voluntarily sacrifice payload capacity to carry extra fuel for disposal if their competitors aren't forced to do the same.
Wow. We have covered a massive amount of ground today.
You really have.
From the sheer physics of a vacuum impact to the economic incentives driving the new space race. Let's bring this full circle for you listening. Think about the incredible journey we've just mapped out over the last hour.
It's quite a story.
We started with a rogue piece of metal, the size of a school bus, wandering aimlessly through the void, pushed subtly off course by the physical pressure of sunlight.
The solar radiation pressure, yeah.
Right. And on Wednesday, that metal is going to violently slam into the moon at over 5,000 miles an hour, creating a crater 60 feet wide and throwing a 50-kilometer-high plume of pristine, untouched lunar dust into the vacuum of space.
And while astronomers around the world point their telescopes at that plume to unlock the history of our solar system and calibrate their models of asteroid strikes, we must also grapple with what this event symbolizes.
Exactly. We have to remember that this is a symptom of a much larger disease, a creeping space junk cascade that threatens our very access to the stars, driven by an economic system that prioritizes speed and profit over sustainability.
It's a wake-up call, really.
The next time you walk outside and look up at the moon, I want you to see it differently. Don't just see a silent, romantic rock in the sky. See it for what it has truly become, a highly active, real-time scientific laboratory, but also increasingly a growing graveyard for human ambition and carelessness.
And as we reflect on all of this, I want to leave you with one final synthesis to ponder, something that ties the biology, the physics, and the carelessness of this entire deep dive together.
Oh, lay it on us.
We discussed earlier that the 2019 parachute crash likely left thousands of indestructible tardigrades on the lunar surface, sleeping in a glass-like state.
Right, the water bears.
We also know that this 2026 SpaceX crash on Wednesday is going to violently churn up 12 feet of unexposed, completely pristine, subsurface lunar chemistry.
Okay, I see where you're going with this.
This raises a highly provocative thought. As humanity continues to haphazardly throw metal at the moon, could these accidental space junk crashes be inadvertently mixing Earth's resilient biology with untouched lunar chemistry?
Wow.
The moon's environment is not static if we keep bombarding it. Are we fundamentally altering and contaminating the very environment we are desperately trying to study long before we ever even get the chance to build a permanent base there?
That is a haunting thought. Are we permanently ruining the laboratory before we even open the front door? We'll leave you to chew on that one. Thank you so much for joining us on this deep dive into the SpaceX lunar crash.
Thanks for having me.
We explored the physics of the void, the chaos of orbital mechanics, the biology of extreme survival, and the earthly realities of our crowded cosmos. Keep your eyes on the news this Wednesday, keep looking up, and most importantly, keep asking questions. Until next time, remember that the silence of space is currently hosting a very loud 4-ton collision course. Take care, everyone.